Hi, so today I've got question 1 part F on map 2018, and in this question we have a particle moving about on the xy plane. It starts at 0, 0, and this particle it can move either 2 to the right and then 1 up, or 1 to the right and then 2 up. So basically we translate by 2, 1 or by 1, 2. And we want to know what is the closest distance it can get to the point 25, 75. Okay, well, if we wanted to get to 25, 75 from 0, 0, 75 is 3 times 25, of course. That means that to get to 25, 75, we'd need to move up 3 times as much as we'd need to move to the right. But if we look at the translations we're allowed to make, they allow us to move up vertically either only half as much as we do along, or at best twice as much. So bearing in mind we want more vertical height to horizontal distance than either of our translations allow us, it makes sense to me that we would use this bottom translation as much as possible because it's closer to what we want, and probably not even use this top one at all. The other way to think about it is, if this here is our xy plane, then this line is given by multiples of this top translation 2, 1, and this other line is given by multiples of this bottom translation 1, 2. So if we only use this 2, 1 translation, then we'd end up somewhere along this line. And if we only use the 1, 2 translation, then we'd end up somewhere along this line. And if we used a mixture of the two, we'd end up somewhere in the middle. But the point we want to get to, 25, 75, is way up higher than the 1, 2 line. So to get as close as possible to this point, we want to be somewhere along this line. So that means we would only use the translation 1, 2 and none of the 2, 1 ones at all. Now if I pick any point P on this line, this P is going to have coordinates x, 2x, right? The y coordinate is going to be twice the x coordinate. So if we wanted the distance between 25, 75 and P, then we do the usual thing of viewing this as a right-angled triangle and using Pythagoras' theorem. So let's look at the distance squared actually, so we don't have to deal with any square roots yet. So we get 25 minus x squared from the horizontal difference and 75 minus 2x squared from the vertical difference, right? And the distance is minimized when the distance squared is minimized. So to find the minimum distance, we just need to minimize this. And this is just a quadratic. So let me call this d just to make it easier. Okay, so we want to minimize d, which is just a quadratic. So we'd want to differentiate and set the derivative to 0 to find the minimum. But let's begin with just expanding out and simplifying this right-hand side. So here I've just expanded each of these brackets out and I've collected the x terms here. And 75 is 3 times 25, so we can write the constant bit as a multiple of 25 squared. So this is our final expression expanded out and simplified. We can also factor 5 out. And the 5 is a constant, it's fixed. So to minimize d, we actually just want to minimize what's in this bracket here. So let's call this in here d hat. So we want to minimize d hat, and to do that we want to differentiate. So differentiating, we get 2x minus 70, and to find the minimum we set this to 0, which of course gives us that x is 35. So the distance between 25, 75 and P is minimized at x equals 35. And because we're on this line, y equals 2x, then we know that the y coordinate of the point must be 70. So we have a distance that's minimized at the point 35, 70, and now we just need to find that distance. So using Pythagoras like before, we do 35 minus 25 for the horizontal difference, and 70 minus 75 for the vertical difference, and now just working this out, we get 10 squared from this and 5 squared from this. 10 squared is 2 squared times 5 squared, and so we can factorize a 5 squared out of the square root. So that's this 5, and 2 squared is 4, so 5 times square root of 4 plus 1, 5 root 5, and that's answer B.